So now we're going to do the same kind of problem, i.e. a problem involving money again and totals again, but we're going to set it up differently. So the last problem, we set it up with two different equations using both x and y. See those variables in there? But in this problem, we're not going to set it up that way. We're going to set it up with this little notation business that they give us here. So let's read it through. We have a 6,000 seat amphitheater. It will sell tickets at $20 and $35 for a PJ Harvey concert. Let X and Y be the number of tickets that will sell for $20 and $35 respectively. Assume that the show will sell out. Okay. So let R equals F of X be the total revenue in dollars from selling $20 and $35 tickets. Find an equation for R. Well, couple of things. A whole bunch of stuff is different on this problem. For one thing, they told us the variables. They say it right here. X and Y be the number that will sell for $20 and $35 respectively. So when we have this right here, we can just say to ourselves, okay, look, X equals the number of tickets sold at 20 bucks. This is a totally different problem than the last one we did, because the last one we did, we didn't know how much we were selling them for. Remember, price itself was what we didn't know. Let me go back here. It says, what should the prices be? Right there. See that? What should the prices be? You're looking for price. That's why at the end I had to put dollar signs on the answers. But in this one, I know how much I'm selling them for. I'm selling them for 20 bucks and 35 bucks, right? So it's not price I'm looking for. It's going to be how many of each type, right? How many do I sell at the low price? How many do I sell at the high price? All right, so then if that's the case, and I know how many I'm selling them for, let me just put this in here. See? There we go. Okay, so Y equals the number of tickets sold at $35. Okay? Now, keep in mind, they gave us one other piece of information. It's right here. Well, actually, it's two pieces. So they tell us that the concert's a sellout, and they tell us that there's 6,000 seats, right? So if you sell it out, that means every one of those 6,000 seats are sold, which means X plus Y, X plus Y has to be 6,000. Has to be. All right, we'll keep that in mind for later because we're going to need it. All right, but all of this is kind of setting up some information, like information that they're giving us, but it isn't actually answering their question. They want to know what revenue is as a function, but they want it only as a function of X. So they want to say, hey, your revenue is a function of X. Revenue is the fancy business term for money taking in, right? How much money are you bringing in? You raking in the dough. Okay, so we need this to be a function of X. Now, money is going to be based on how much you sell it for, right? So if you sell tickets at 20 bucks, you say, okay, that's 20X plus 35Y. For every ticket I sell at the $20 price, I get 20 bucks. So if I sell 10 of them, I get 20 times 10. If I sell 30 of them, I get 20 times 30. Similarly, 35 times Y, because for every ticket I sell at the $35 price, I'm going to get 35 bucks. But the problem is that there's too many variables over here. This is X and Y. That's no good to us. We can't have X and Y. They said to only make it a function of X. That's a problem. We need to make Y disappear. But this is where the X plus Y equals 6,000 thing, the sellout thing, that becomes handy to us. Because if X plus Y is equal to 6,000, that means Y is equal to 6,000 take away X. You can subtract X from both sides. That's nice, because once I know I can do that, then instead of writing 35 times Y, I could write 35 times 6,000 take away X. That would work, right? It has it so that the revenue is not just, is not both X and Y, but is just X. Actually, let me take a moment here to write revenue was equal to 20X plus 35Y. So there, that kind of gave us both of our equations. The issue is that it was no good to us with the Y. So we had to make the Y part disappear. And we did that by doing Y is equal to 6,000 minus X, right? So by taking care of that, oh, I don't want to use that. Sorry. There. Oh, gosh, no. That's way too bright. It's not going to work at all. There we go. All right, so I had to make y disappear because they only wanted it in terms of x. So I used the fact that it was 6,000 seats and sold out, and then I used that to make that equation, and then I solved it for y, and then I very craftily brought it over to the other side. There you go. And made it so that it was all one function right here once I got it over there. Okay, so let me reiterate. X plus y has to be equal to 6,000. That's because they tell us that it sells out. So all of this is really based on that aqua part right up there. The fact that it's a sellout and stuff. And then the revenue part, the whole 20x plus 35y, that part's coming from right here where they sell, that they're selling the tickets for $20 and $35 right there. Right, so that's going to be your revenue. Well, they tell you up here as well. They tell it to you twice. They didn't really, oopsie, they didn't really have to. Okay, so you're going to get 20x plus 35y, and then you've got to solve it for y to get rid of the y in here because you need to get rid of it and make it just x. There we go. So that was what they were looking for, is this guy right here. Now, the only issue is that it's not really simplified, which is kind of not good. So we should probably make it so that it's all simplified. So we'll say, okay, that's 20x plus 210,000 minus 35x. Again, I just multiplied that with my calculator. So that's equal to negative 15x plus 210,000. There's your revenue as a function of x. Right here. Nothing but x, no y involved at all. I suppose I should write it like this. There we go. And again, revenue is just a fancy term for how much money you're raking in. All right, so now we're going to use a graphing calculator to graph that equation for that value. So I'll pull up my calculator. Kind of move it over here so I can see it. Oopsie, not that far. All right, y equals, I clear out my old equations, and then I type this in. Negative 15x plus 210,000. Now they tell us right out that they want us to go for x is 0 to 6,000, so that kind of makes things simpler. So I press window. I'm going to go 0 to 6,000. Okay. Now y in this case isn't the y from the 3,500. It's y for this guy, which is your capital R, right? Your revenue. So how much money are you going to make from this concert? Well, you can see that the highest you could ever get is 210,000 because your y-intercept is 210,000 and you drop 15 because this is a, oh goodness, I've lost my equal sign in there. That can't be good. All right, so you can see that, you know, it's got a negative slope, so it's going down. So you can say, okay, my max is 210,000, but my min, you can make it 0 because you can't really have negative revenue, right? So that would work. And then what do you want your scale to be? It doesn't really matter. I'll pick like 1,000. Actually, I'll pick 10,000. And then up here, I want the scale to be, I don't know, if I did 1,000, that makes 6 tick marks in there. How about I do 500? That'll make 12 tick marks. That'll be good. And there we go. And you can see I got 12 tick marks right there. And right, and then I'm going to draw this graph. And again, with me, it's a whole lot easier than it is for you. But you draw a quick sketch of it. Oopsie. And you don't press delete on it accidentally. Okay. All right, so now what was the slope and what does it mean? Okay, so you can tell this is linear. It's mx plus b, right? So what's the slope? It's negative 15. But we can do better than that. It's negative 15 over 1, right? And then let's think about what slope is. Slope is your change in y over your change in x, right? Or your change in your dependent variable over your independent variable. So this is revenue dollars. Oops. Revenue, because that was your y for this variable, this equation up here, this function. Revenue was your y variable, excuse me. And then your x variable was the tickets you sell at 20 bucks, right? So this is number sold. Where's the number key? Oh, there it is. Number sold at $20. Okay. Now, I know you think I'm crazy. You're thinking, I don't need to do that. I can just say the slope is negative 15 and I'll be totally fine. It's like, yes, you're right. It is negative 15. Negative 15 is the actual answer for that part. However, it really pays to write it out a little bit more for yourself because you have to explain what it means. Writing the number negative 15 is worth 1 point. Explaining what it means correctly is worth 4 points, right? So you can't pass the class just by knowing it's negative 15. You have to be able to kind of break it down for yourself. So it's negative 15 over 1, and then say what the units are. It'll help you. So that was revenue dollars, right? Because revenue is in dollars. It's how much money you bring in over number sold at 20 bucks. Okay, so what does this mean? So what you're doing is you're saying, look, I can see it's going down at a steady pace, and that negative 15 is that steady pace. What does it mean for the sake of this concert? It means every time I sell, for every ticket sold at $20, the concert makes $15 less in revenue, right? Because every time you sell a ticket for 20 bucks, that means you're not selling it for 35 bucks, right? Which means you lose 15 bucks every time you sell a ticket at 20 bucks. Now the deal is, though, of course, that they always do that. They have to strike a balance, right? Because the bad seats, you can't charge them 35 bucks for bad seats, right? But every time you do that, then you're losing $15 in revenue because you're not getting to charge them that higher price, right? All right, now what was the R-intercept and what does it mean? So the R-intercept is, from this equation, the Y-intercept, right? So R-intercept is when x is equal to 0. X is equal to 0, which would mean R is equal to 210,000. So I guess I should just make a point out of this. The R-intercept is 0, 210, right? There's your intercept. Gotta be, right? Because it's your Y-intercept. Your Y-intercept is when x is 0. That's what the whole mx plus b thing is. That b is that Y-intercept. In this case, R-intercept. Now, what does it mean? It means if we, I don't know what I'm doing there. If we sell 0, okay, now that was your x. X was tickets at the $20 price, right? So if that is 0, if we sell no tickets at $20, or at the $20 price, in other words, we charge all people 35 bucks, then the concert will bring in $210,000 in revenue. Oops, and apparently that was the next page, so I'll put that there. All right, now how many tickets must be sold to make the revenue 135,000? So what you're going to do is you're going to take 135,000 and put it in for R. I got to pause you and do that. Hold on one sec. Right, so I set the equation equal to 135,000. So where there was R, I now put in 135,000. And then you have to solve this for X, right? So you're going to subtract 210,000, and then you're going to divide by 15. Negative 15, right? So there you go. You got negative 7,500. Then you divide both sides by negative 15. Which means when you divide that, you'll get 5,000. So you need to sell 5,000 at the $20 price. Now remember, it's sold out and there's 6,000 seats total. So to find out how many at the other price, you just need to subtract from 6,000. Like that, which means 1,000 at that price. Like that.